The first atomic model is the Dalton's in this atomic model, Dalton consider in the year 1803 AD, the Dalton suggested this atomic model, and he considered it as he suggested that every matter is made up of the atom. First thing, he suggested that every matter is made up of the atom, right? And this atom is solid sphere. It is a solid sphere. This atom is a solid sphere. तो जो ॲटम असणार आहे तो पूर्ण भरलेला अशा पद्धतीचा सॉलिड असणार आहे त्या ठिकाणी, असं त्यांनी त्या ठिकाणी सांगितलं डाल्टननी. अगेन देर इज and this solid sphere is without any structure. This solid sphere is without any internal structure. This solid sphere is without any internal structure, and the mass of this atom is uniformly distributed inside this atom. The mass of the atom is uniformly distributed. The first model, which is suggested by the Dalton, it says that every matter is made up of the atom, and this atom is a solid it is a solid sphere without any internal structure, and the mass of this atom is uniformly distributed. It is uniformly distributed inside the atom. It is uniformly distributed inside the atom. Right? This was the first model of the atom. It says that how the atom exists. The Dalton says about this model that this is the solid sphere and it has no internal structure, and because of this it doesn't tell us about any internal structure of the atom. This was the drawback of this model. Then the next scientist, which is the J.J. Thomson, introduced the next model of the atom, J.J. Thomson's atomic model is like this. J.J. Thomson, this model is also called as the plum pudding model. This is also called as the plum pudding model. In this model, he says that it is like a plum pudding. In the festival like Christmas, we made the puddings, and we make the cakes for the celebration, and over that cake we spread the different types of the raisins, kajus and badams on it. So in the similar manner, त्याचप्रमाणे म्हणजे आपण एक केक तयार केला आणि त्यावरती काजू आणि बदाम जे टाकतो त्याच्यावरती, तर ते कसे स्प्रेड झालेले असतात, तर त्या पद्धतीनं ह्या मॉडेलचं त्यांनी डिस्क्रिप्शन केलेलं होतं. त्यांनी फर्स्ट सांगितलं होतं की दिस ॲटम there is the evenly or uniformly spread positive charge is there. ह्या ठिकाणी पॉझिटिव्ह चार्ज हा स्प्रेड झालेला असतो ॲटममध्ये अशा पद्धतीने. The atom is made up of the positive charge. Atom is made up of the positive charge. Atom is made up of the positive charge. Such a charge are distributed there inside the atom, and the electrons are embedded in it, and the negatively charged electrons are embedded in it. Such type, the negative charges are embedded inside this positive atom. Right? The electrons are embedded inside this atom, and the number of positive charge is equal to the number of negative charges are there, which are nothing but the electrons. The charges are exactly equal in the atom, and hence this atom is electrically neutral. Atom is electrically neutral. This is the model suggested by the Thomson, Thomson, in which he says that the atom inside the atom is positively charged, and these electrons are embedded inside it. The number of positive charges is equal to the number of negative charges, which are nothing but the electron, and hence because of these things the total exactly opposite numbers are there for the positive charge, and the negative charge are equal in numbers, and so that this atom is electrically neutral. Then the next atomic model is of Rutherford suggested one atomic model. Before suggesting this atomic model, he performed one experiment, and that is nothing but the Rutherford's scattering experiment. Let us see the next model, which is the Rutherford's atomic model. Rutherford's atomic model. Before explaining this atomic model, he performed one experiment, and that experiment is nothing but the Rutherford's scattering. We call it as the scattering experiment. Scattering experiment performed by the scientist Rutherford. In this experiment, he used one gold foil and a scintillation screen. This is the screen. This is the screen which he used to observe the radiation of the particle. Inside it, he uses one gold foil. This gold foil has the diameter less than, this is the gold foil which has the thickness less than 10 to the power minus 4 millimeter, which has the thickness less than the 10 to the power minus 4 millimeter, and this gold foil is bombarded through a radioactive element inside this. This one is the lead box, and inside this lead box, this one is the lead box. Inside this lead box there is the radioactive substance. Here he kept a radioactive substance, and this one is the radioactive substance. radioactive substance which emits the alpha particle or the alpha rays, which emits through this and which passes through the gold foil. In this way, he performed the experiment. He uses the scintillation screen, or this one is the fluorescent screen, where he observed. This one is the fluorescent screen over which he observed the incoming alpha particles. So, after doing this experiment, he concluded that what he find, when the alpha particles or alpha rays are bombarded over this gold foil, this one is the gold foil which has the thickness less than 10.4 millimeter, it is very thin. What he find, some alpha particles are, most of the alpha particles are passed, or these are the passed forward, right, as it is, without changing its path. The alpha particles pass through this gold foil without changing their path, move forward, and some particles change their direction, which are very less in numbers. The conclusion of this experiment is, first conclusion is, most of the alpha particles or the alpha rays pass forward as it is, without changing their ways, without changing their change in their direction, they move forward. Without changing their direction, they move forward, and very few alpha particles change their direction. Very few particles change their These two conclusions were drawn from this scattering experiment. What he used the fluorescent screen to observe the deviation of the alpha particle, which is emitted by this radioactive substance which is kept inside the lead box. लीड बॉक्सच्या आतमध्ये रेडिओ सबस्टन्स केलं होतं, त्यांनी ठेवलेला होता. अँड दिस रेडिओ सबस्टन्स आर हायली इनस्टेबल इन नेचर which emits the alpha particle. These alpha particles are transferred to this gold coil which has a thickness of 10 to the power minus 4 millimeter. And what he observed on the fluorescent screen वरती त्याला काय ऑब्झर्व करायला मिळालं की these alpha particles, most of the alpha particles pass through this gold foil without changing their direction, but few of them change their path with a certain direction, change in their direction. They are very less in numbers, and with this conclusion the scientist Rutherford put the structure of the atom such that there is, first of all he says that let us discuss about the atomic structure. In the atomic structure he says that there is the inside positive charge, there is a positive charge, and the electrons are revolving around it. Negatively charged electrons are revolving here. The atomic model suggested by him is there is the positively charged nucleus is there. Positively charged nucleus is there, and second one, the total mass of the atom is concentrated at the center. Nucleus is at the center, and the total mass is concentrated at the center. Total mass of this atom is concentrated at the center. The next thing he suggested in the atomic structure that there is the electrons revolves around this nucleus. Electrons revolves around the nucleus. These are the electrons which are revolving around the nucleus are same in the number. The positive charge, number of positive charges are equal to the number of negative charges, which are nothing but the electrons which are revolving around the positive nucleus. Both are same in the amount, their number are equal. So this atom is electrically neutral. This atom is electrically neutral. In the model of Rutherford, he suggests that this atom is electrically neutral. And one more thing he added in his model, that there is the empty space or free space. This one is the free space inside the atom. He added in his model that there is a free space between this nucleus and the electrons revolving around it. This atom is electrically neutral. But he failed. The drawback of this Rutherford's atomic model is that the model is unable to tell about the stability of the atom. We know that every atom in the nature has it is a stable in a nature, but this model fails to tell about the stability of the atom, and which is the drawback of this model. So that the next scientist, Niels Bohr, atomic model was accepted. Let us see the next model of the Niels Bohr's atomic model.